day to you. This is Anagalactic on the 6th day of February, Thursday, here in Chico, California. We are in the synthetic phase of a study of cosmic geometry. The synthetic phase is the exciting phase. It's once you've gotten all of your... This is a book by Luca Guzzardi that you can get for free. The Boschkovich force curve. But look at that caption. Points, distances, determinations. That doesn't sound like natural philosophy to me. So the synonym for science in Ruggiero's day was natural philosophy. Well, natural is the key word there. It's not general philosophy. Instantaneous annihilation of velocity. Light speed is the rate of time in space. What then is light length? Well, light length is Planck time. What is Planck time? It's the ratio of time into space. That's Planck time. That's why nobody can compute it. It's the same age-old quantum paradox. The quantum of time, there is no such thing. Technically, there's no such thing as the Planck length either. Is there such a thing as light length and light speed? Yes, light is real. But is space real? Hesitate before you answer. It's relatively real. Is time real? It's relatively real. Is light real? Yes, light is real. That is what we don't understand. Now I'm going to read a quote from Lancelot Law White, who wrote in 1961. I've covered this in 2 videos. A very good short book I recommend reading. You can get it for free. It's called An Essay on Atomism, which I just abbreviate atomism. It was Roger Enderton who turned me on to this book. Thank you, Roger, although I know you don't give a hoot about me. You're too busy with your Einsteinian upstart physics, which you'll never solve. So that's for you, Roger Enderton, whom I love. As we have seen, if a unified theory is possible, the laws which cover the new micro-world as well as the old macro-world must be generalizations of the known laws. Think about that. To be reached by dropping unnecessary restrictions concealed somewhere in the quantum mechanics of 1929. Now, what does he mean by that? He's attempting to point theorists in the right direction so they can overcome the theory and get the solution. That's what I got. He's talking about what a man would do to get the answer. And that's exactly what I did, so that I did get the answer. So what are the unnecessary restrictions concealed somewhere in quantum mechanics? It's the number system being used. It's a 1-component number system. I discovered a 2-component number system that replaces complexity and solves for imaginarity and infinity. Well, that would be, if it can be proved, the most important discovery in 120 years. The theoretician is not completely in the dark in exploring the nucleus, but his lamp is the wrong color. It's the number system that's screwed up. It's too simplistic. Relativism implies 2 quantities. That's what relativity is. It's the relative aspect of 2 completely different quantities. You can't use a 1-component number to get what amounts to the rate of change between them. That's a 2-component number. Newton proved that. It's a rate. That is a fraction. There are 2 numbers in a fraction. So light speed is 2 linear numbers. A rate is not a number. Kilometers per second. It looks like a number, it's a fraction, and so we use division to reduce it to a linear number. But they're 2 different data types. The 2-component number represents curvature. Is a circle a 2-component number? It has to be because it's in a 2-dimensional plane. So to represent a circle, you need 2 linear numbers. Sine and cosine are not linear numbers. They're irrational numbers. In a grid, you have to have quantization on an index, which means everything is a whole number in the grid. But we're not measuring the grid. We're measuring something that goes in between all the points on the grid. That's a circle. Now that must be a two-component number. What about the sphere? Obviously that is one dimension higher, even if you conceive the plane to be a circular plane instead of a squared plane. It's a circularized plane. That would be concentric circles measuring distance out or in, instead of left, right, up, down, and in, out, which does not work because one of those components has to remain imaginary. Things disappear in 3D space. They pass out of existence as you rotate. That's called gimbal lock, or division by zero. That does not occur with a two-component number system because the two-component number system is based on the multiplicative identity instead of the additive identity. The additive identity is zero. That's an imaginary infinity. The dyadic fractions, the power of two fractions, compose a separate number space. So 6.28 is a fundamental dimensionless constant of the universe. Euler assigned a name to that number, but it never caught on. In fact, he wanted to call it E, but I guess that left him free to use E for something else. A lot of people say that Euler named it after himself. No, he didn't. That's ridiculous. Euler would not do that. Only modern men do that. But it was renamed in the 21st century, believe it or not, when a consortium of mathematicians around the world got together and had a party. They started communicating with each other, and they said, hey, we got to drum up some port for our new number, which is a new name for 2 pi. And they called it tau. And tau is interesting. It's like the pi symbol. You've seen the cute pi symbol that 3 blue, 1 brown uses. An amazing young man out of Stanford whom I admire so much is unbelievable. That guy is powerhouse. And his technology, I just drool over it. But everyone loves his pi symbol. It has 2 little legs. Well, he attached eyes to the pies, eyes on the pies. But the right number is tau, and the consortium was right, but of course, it's too late to change anything in science. Science does not have a feedback system. The radius to the circle maintains that 6.28 relationship. What is that constant for the sphere? It's about 12.56. So what does that mean? It means that our number system is crippled. This is called GeoGebra. I've given several lectures on how to use GeoGebra. It's probably the most amazing tool for geometry of all time. And so they don't have to release it for free. They do. They release it for free. You can use it online, so you don't have to download it. Now, the purpose of this particular presentation is kind of diffuse because I want to show you a lot of things, but I do intend to concentrate on the Boschkovich force curve, which, by the way, that curve that you saw going up and down, it is a sinusoidal wave, but it's showing the intersection of 2 spherical force fields. And every sine wave represents something in circular space. And whenever you see the sine wave, you know, there's sine squared plus cos squared equals 1. That's where we get our probability theory from for quantum mechanics. Those squared numbers cannot penetrate to circular space because they're not 2-component numbers. You add them. According to the Pythagorean theorem, you're using the additive identity of the line. Well, we don't want that anymore. And this is the turning point of science. We need to switch number systems to the integral number system, which is 12 times more powerful in volume space and is 6 times more powerful for accuracy, 6 times more powerful for circular space. Well, that's power. Instead of using this simple transition to the integral number system, we use complexity and hypercomplexity. Those are tools. They're actually new operators. And calculus and hypercalculus. Dirac discovered hypercomplexity. Einstein discovered hypercalculus. This is going the wrong way but it's contextual because it's superpositional. If you feel that you're forced to use linear numbers, and there's a very good reason for that, they contain the computable numbers. But what nobody's noticed, not even from computational science, is that the computable numbers, first of all, have to be representable numbers on a computer. Those are the dyadic fractions. Those are the only actual numbers. And they're fractions, so they're two-component numbers. Well, that is a match on light speed and spacetime. You'll see in this list, graphing. Scroll up, it says circle with center through point. It should say select center point and then move the pointer to create a circle. So that's what we're going to do. This is a smart program. It knows to snap on one, and there's our circle. Now we can compute the circumference. This is a unit circle, virtually worshipped because it shows the mathematical relationship between the radius and the circumference. As you know, that is the number tau, which is the correct designator for 2 pi. And the reason for using tau rather than 2 pi is that 2 pi has a coefficient, whereas tau is a unit number. So, the unit number for what would be construed as the linear distance around the circle, which is a direct contradiction as I'll show you, but you could say that the circle has a value that can be reduced to 1. All right. You'll see that the vertical aspect is 1 and the horizontal aspect is 1. That is the proportion of 1 to 1. The proportion of 1 to 1 is 1. And those are two different numbers. They are equivalent in a sense, because in order to use numbers at all, they must be linear. A two-component number is not computable. Any fraction on a computer has to be reducible to a linear number. A fraction is not a linear number. I know we were taught in school that fractions are linear numbers. No, they are not linear numbers. I'll be showing that to you. What we want is to put the number 1 proportion 1 onto the circumference. In order to do that, we have to know the constant conversion number, and that is tau. So how do we get 1 from the radius to the circumference? What we want is a circle whose value at the surface to be 1. But since it is a two-component number, it's 1 over 1. And that's a different representation of the linear number 1, but it's directly reducible to 1. So quantitatively, they're identical, but relationally, they're not. 1 over 1 is a much different form of number than just a single component 1. All right. All right, we're back. You can see I got a little dressed up there. I was still in my morning attire. Instead of the linear jump from 0 to 1 to get the index, which would be now considered the Planck length, meaning that there's no number less than 1. So it depends on scale. We are trying to get the smallest scale. That would be the Planck unit of linear separation. That's the distance from 0 to 1, which involves a contradiction called the quantum paradox. What we want is, in a sense, to make it worse. Because the actual quantum jump is not through linear space. So the Planck length is virtually a meaningless term, but it has the same meaning as the number 1 on the radius of a circle. So you can see that the actual Planck jump is 6.28 times greater in area. And that's a change of dimension. So it's one of these days I'm going to try to compose a list of all the ways to define the quantum paradox, the quantum jump. The quantum jump on the unit circle is the jump from the center to the surface measured on a line. There are two answers, depending on context. If you want the ratio of the circle to a computable number, then you must use the index of computable space, which is the Planck length. So the radius of the Planck circle is that unit, which has units. In other words, it's not just an abstract quantity. It's a contextual quantity that has to do with the nature of the line, which Euclid said is the shortest distance between 2 points. This goes to entanglement because the shortest distance to 2 points is only in linear space. It can only be on one of those. It has to be on a line. It's not in any other direction or dimensionality. It's just straight distance. That radius is a linear distance. So that is called the quantum jump because there is no actual numeracy between 0 and 1. In other words, the smallest distance is 1. What does that make 0? A dimensionless point is how Euclid defined it. That works for linear space. That remains consistent, but it does leave a very peculiar... You would have to put it here, just a philosophical problem of what then is 0. What is a 0D point, which is two different questions. So what we want is to replace the linear quantum jump from 0 to 1 with a jump from the center to the surface. Now, the way we conventionally say that, which is a bit misleading, so you have to be cautious, but it's a jump in all directions at once. That can be much better stated, much more logically and precisely. It's a single jump in circular space. And it's only by reverting to your linear point of view that you say it's in all directions. No, it's not in all directions. It's in all linear directions. It's only one direction in circular space. Now, I'm going to show you something, and this is the main purpose of showing you this transformation, which is a simple geometric and mathematic transformation on an irrational constant. Irrationality we must have nothing to do with, because it can be proved that in linear geometry, the unit of distance is 1. It just depends on how big you think that 1 is, but it is defined as the jump from the center of the line to its first distance. That should be said its first measurable distance. This goes to the measurement problem of quantum mechanics. Is what is that distance if there's nothing smaller? That's quite a paradox. We're on our way to solving it by integrating it. But it does lead to the same paradox, because you have, in order to have computable space in a geometry, you have to have a computable index. The computable index of linear space is 1 because that's our conventional name for what is now called the Planck length, which is quite difficult to define. First of all, it's incredibly small. It's about 10 to the negative 34th power. But one aspect of that paradox which you should be aware of, this is kind of an interjection, but I'm not trying to get off course, but it's important for you to see that if there is indeed a Planck unit of distance, then Albert Einstein proved that there must be a Planck length for time. That has actually been computed using I'll just say a mathematical system. It's 10 to the negative 44th power, which these numbers are ginormous, okay? And they're ginormously small. So the Planck time is approximately, well, it doesn't really make much difference what the decimal coefficient is, 1 through 9, because the magnitude is so extreme. But it is part of Zeno's paradox, and it is part of the quantum theoretic approach that there must be a quantum of everything. We already know that from the line, or we wouldn't have numbers, we wouldn't have distance. So we know there's such a thing as computable linear distance. Is there such a thing as computable linear time? According to a theoretic model, there is, and it's 10 orders of decimal magnitude smaller, but you have to know what the units are. So this would be a fraction of time. conceived as a linearizable quantity. Well, another thing that Einstein proved is that space and time are related linearly. He proved that that's true, and it's true on a derivative. It's the derivative of time from energy, and it's the derivative of linearized space from spherical space. Now, what we're going to do is integrate that so we can get a one-component number for space-time. And the way this was discovered, essentially by Max Planck, and then I needed to interpret what Max Planck discovered, but with this new geometry I was able to do so. We now are capable of relating space and time in one number. Now that is thought to be light speed, which would be the index of spacetime. Light speed is the index of spacetime, but spacetime is a two-component relational system. Light speed is a two-component relational expression. So it's an expression of a system in two-component space. That is not linear. What we're going to do now is compose the two-component space, but you have to capture linearity, because you have to be able to transform the spherical numbers. First to make your expression for your equation, and then in the result you'll have a two-component number. You need to extract the linear numbers to prove that the two-component number is computable. It's an interesting split, and you'll notice there's a split. It's the split from one-component number system to the two-component number system. Here's how to do it. First, we need the identity number for circular space. We have the identity number for linear space. It's the additive number 0, which also is reflected in subtraction, that 0 anywhere in the equation has no effect on the quantities. So 0 is a absence of quantity, and therefore it does not affect distance. All right, so that's the identity number of additive space as we were taught in school. We were also taught that there's a multiplicative identity, and just the way I phrased it, you would have to assume there must be a multiplicative space. You're about to discover it, and this is not in any textbook or any classroom, that the two-componency system that the universe uses is in fact circular space. A remarkable oversight. But that will lead to the solution to all of these paradoxes at its mathematical basis, is that we must switch to the integral number system. Just volumetrically, the increase in precision is sixfold. But that's actually not the most important aspect. That's a linear point of view that I'm showing you. The true significance is the interdimensional constant that regulates how to extract or compose circular numbers from linear numbers or linear numbers from circular numbers. The linear numbers are based on a quantum jump on a line. The circular numbers are based on a quantum jump in circular space, which is planar. So we're not squaring the space. What are we doing? We're tauing the space. We're tauing the space. In order to get the identity number of the number system, that would be 1, we can prove now that that number 1 is a circle, and it is the quantum circle. In other words, it's the smallest circle. So now we want to derive the Planck length in these units, which must be a linear number. That will be the radius of the circle whose value is 1. So it's going to be a fraction of 1. It'll be about 1/6. And if you divide 1 by 6, the linear number that is reducible from 1/6 to its linear representation is a decimal fraction of about 0.16, because 6 times 16 is 96. But you're not quite there, but you're close. So on a whole number ratio, it's about 6 to 1. We want to be more precise than that. We can compute the number tau and then take its inverse. So tau, written as a two-component number, is 6.28. That's 2 more decimals of precision. It is an irrational number, so it's an arbitrary cutoff point for the precision. But this is forced in linear mathematics, and calculus helps us do that, but it doesn't actually solve the problem geometrically. So we can't get rid of the irrational number in linear space. That fact will become critical in a moment because we're going to solve that ancient problem. We're going to solve several ancient problems now, and this will lead us to the solution of the entire quantum paradox system. So this is the mathematical basis of the transformation to the new number system that solves the quantum paradox. All right, we need to show that at 3 levels: mathematical, geometric, which is the transformer, and in physical reality using measurements. So we do have to rely on measurements that have already been made. But in geometry, you actually don't do that. Once you're done with your geometric solution, then you prove it with the mathematics. So you do have to be able to visualize the mathematics first in order to achieve your geometry. We don't have a circular geometry, which means we cannot compose a spherical geometry. That's what's missing. That's what I discovered. So to get to spherical geometry, we begin with circular geometry because it's planarized sphericity. And there's a known fixed constant relationship between a circle and its sphere. You notice I said possessive. A circle and its sphere. The circle is the eigen of the sphere, and every sphere in the universe at all scales has an eigen, which means there is one and only one circle that is associated with any sphere, and the sphere defines the circle, and the circle defines the sphere. Now, you can see there's a little loophole there. The circle defines the sphere, but the sphere defines what's called a fibration of circles, which is an infinity of circles, because you can orient the circle randomly on the sphere. But no sphere in the universe is like that, and therefore no circle in the universe is like that. It's not random, because there's always angular momentum attached to a sphere. A sphere is actually the manifestation of angular momentum. That becomes peculiar when you look at gravity, which is spherical, but there does not seem to be angular momentum. There is no way to see the angular momentum of gravity in linear space. Actually, it's a physiological hindrance. I'll show you how to see beyond what your body is capable of. It's the true probe into imaginary space. I'm going to show you what imaginary space is. And it's not fantastical. That's demoting its position to, oh, it's imaginary, well, then it's not real. No, you go the other way. Because we cannot see it, and yet it is there, it must be superspace. All right? It's an integral that goes beyond our capacity to see with our onboard perceptual system. I'll show you how to turn that on. And when it does, the result is somewhat unpredictable. There is a tiny chance, many say, that you could lose your mind. I say that you don't want to say lose your mind, because that sounds like you can't get back. You have to suspend your mind and then try to turn on another part of your mind in its place. That is almost a clinical definition of psychosis, but it doesn't last long. But it is I do need to warn you. I got such a tremendous... I've gotten many of these jolts throughout my career in science, which does extend to scriptural science, but I don't expect you to credit that because of your educational system prevents you from crediting that. So what we want here is a circle with the inverse of tau as the radius, correct? That would be about 0.16. we're going to use the number 0.159 because that's one decimal of accuracy closer. But it is irrational, so we can't make it precise. I'll show you how to correct for that. There is a way to do that, and this machine we're about to use over here will help us do that. So we need to mathematically justify why we're using the inverse of tau, 0.159, on the radius. What is the mathematical justification for that? The relationship between the circumference of a circle and its radius, I believe, is 2 pi r. Well, you know what 2 pi is. It's tau, and that's the name we're going to use for 2 pi. I hope that does not confuse you. Science will forever pretend to be so confused by that it just simply will not accept that. But you and I are strict logicians. And 2 pi has a factor of 2. We don't want that. We want everything unitized. And that number is tau, 6.28. All right? So, why do I say that the inverse of tau, which would be 0.16 or 0.159, depending on your precision scale, why is that true? It's because of the relationship of tau r equals c. Well, what we want is r, but not in terms of tau. We want r in terms of the number 1. Okay? That's what we want on the radius. And here's how you can see that. I won't draw the mathematical equation. Do it in your mind. Here's the equation we start with, which is known. Tau r equals c. All right? There are no numbers. It's just tau r equals c. Now, because the first term, that is the term on the left, is tau r, you can take one of the factors and make it a divisor on the other side. So now we have r equals c over tau. We know the number for tau. It's 6.28. We're just going to say that. And so r equals 1 over tau. And that's 0.16. So that's the validation, the mathematical transformer. It's a transforming function. It's a relationship. All right. So now we can do the same thing and click on this tool up here for circles. And we want center and radius, don't we? So let's select that. And when I click on the center point, I'm using a different tool than before. It's going to produce a box and ask me for the radius. Click. The radius, 0.159. And now you can see, I'm not sure you can see those tiny numbers. I actually could make them bigger. And I'm learning as we go as well. You can see this gets down to basic mathematics. So the entire circle now is 1. Because the radius is the reciprocal of tau. That's a reciprocal number. So the value of the circle, we will now say, is 1 proportion 1. That's the proportion of the vertical aspect to the horizontal aspect. And the proportion is equal. So this is a depiction of E in a certain context. It's the continuous rate of change in square planar space. And that creates circular space. And the identity number for circular space is 1. That is the circumference of this circle. And therefore, 1 is the center of the two-component reciprocal number system. It's a two-component number that you must conjugate to get the two linear numbers out. So that's a mouthful. I hope you're following this, but this is an interesting step that nobody ever thought to take, is to unitize the circle. The unit circle is somewhat misnamed. It's the linearly unitized surface. The circle is a surface. A line is not a surface. And so the circle can support what is called intrinsic geometry, which is not a grid. The linear number system, in its systematic development into 2, 3, and 4D, is a grid. Obviously, it's squared, cubed, and hypercubed space. And it has to be space, not space-time. In order to have space-time, you would have to at least begin at circular space. Well, there's a pretty profound and sound reason for that. It is the relationship between two quantities, which we're attempting to linearize. The actual relationship is on the surface because the surface is two-componency space. What we're going to prove now is the entire plane is two-componency space with its own number system. Well, that means that we're going to have to make a circular quantum jump. And we're going to need two of them. One for the linear quantum jump to the surface, from the center to the surface. That's 0.16 here. An irrational number in a relationship destroys the relationship. Because there's a certain number of miracles involved in this actually working at all, which is one reason why nobody saw it, is because it doesn't look like it's possible to do. Partially for the irrationality, which must be rationalized. So irrationality is part of the linear system. Is it part of the circular system? I'll show you that it's not. And the way to do that is to put the irrational number off the circle, which is tau. On the unit circle, you have an irrational circumference. Well, we want the circumference to be rational. And therefore, all we needed to do was put the irrational component. By making the circumference the unit of the space, it transfers the irrational number in the relationship to where it belongs, on the line, which is infinitely dense with irrational numbers. But the circle has no irrational numbers anywhere, because the surface itself is the center of the system. Okay, and we know that this is two-componency space, meaning there are two quantities. Okay. But instead of those two quantities being the vertical radius and the horizontal radius, requiring the Pythagorean theorem even to solve, what we want is that relationship between the vertical aspect and the horizontal aspect to be transferred from its extrinsicality, requiring two linear numbers, to intrinsicality on the surface, which is a two-component number embodying the aspects. Now, that cannot be done directly, but it can be done indirectly by observing, first of all, is there any space to a line? No, unless you say that it has a 1D representative, but it's obviously a derivative of space. Well, so is 2D. That's also a derivative of space. 3D seems to catch up with space because now you've cubified space, which makes 8 vertices in space at the edge. That's a solid figure, but it's squared, cubed, and then hypercubed in space-time. What we want to do is go back to the drawing board and realize that we're looking at spherical space, which is here linearized, I'll just put it that way, to a plane. So you're looking at the eigen of the sphere, which is a value of motion called angular momentum. A moment's thought will convince you of that. Every sphere has an eigen of rotation. No sphere is static. The proton does not seem to have spin, although you may know that there are formulations showing that the proton does have angular momentum. That's what spin would be. But spin in the quantum world is actually more of an orientation of the eigen, because spin can be unitized to various orthogonal eigens. And this is where we get some very interesting experiments done on electrons, which can be eigenized, that is, polarized. And the Stern-Gerlach experiment shows that electrons can be magnetically oriented. That is, to orient the eigen. And it's remarkable that it can be polarized. And that's a linear term. Now, the eigen is a prefix that's used in a lot of contexts. And if you're really into quantum mechanics, you may know about the eigenaxis, and there are several other eigens. What an eigen means is that in a certain space, there is one preferred something. For instance, if you have a static sphere, it has no orientation. But the moment you apply angular momentum, it creates two eigens. One is the eigenaxis because it's the part of the sphere that does not rotate. A true linear line is the eigenaxis of a rotating sphere. But it also produces, as well as a 1D eigen, it produces a 2D eigen called the equator. It's the equator of rotation. It's the eigen of the sphere with respect to motion. I'm learning something as I'm giving this lecture, and I'm actually getting a little emotional. I hope you appreciate the depth and profundity of what I'm expressing to you. It impresses me every time. All right. So what we want to observe here is that we're looking down on a rotating sphere. And that circle that you see is the eigen of angular momentum. Is it spatial? You can see that it is. But here's where it gets interesting. It's not linearly spatial. All right. What is it then? It's circularly spatial. Okay. Now here is the critical insight that just breaks the mind if you don't. You're going to have to flicker between two points of view as I tell you what you're looking at. Okay, you accept that it's a closed line because it has no open-endedness as a linear line does. But this is a line. It's just not a linear line. It's a closed line. What does that mean? Let me ask you something. Does a line have an inside? Euclid said no, and science has agreed ever since. So the line has no inside. Well, that means it has no outside. That's tautological. So it's not a surface because it has no inside. That's the definition of a surface. Now, does the closed line have an inside? Okay, I think you're starting to get a glimpse. We haven't gotten to the critical jump point yet, but I'm preparing you for it so you won't have to flicker very long. And this is when you step outside of the box and you're in danger of
losing. Sorry, I got a sip of coffee. Oh, come and taste and see that the Lord is good. If you're not laughing, you're not enjoying life as well as you should, my friend.
All right, a little Joe there. I should pep up the old professor to stop laughing and get on with it. It's the most critical insight you're ever likely to see in your entire life. All right. So we have a closed line that has an interior. Yes.
Yes, it does.
Well, that's really profound that the circle has an inside. You know why? It has an outside. Now there is an outside. All right, that's the extent of circular space. It's circularized space. Well, you know already that the circle represents a sphere. Essentially, you're looking down on it. The equator is the circle. Well, you can see that if the sphere were to expand, let's just say, so would the circle. So we're going to expand the circle to get the quantum jump in circular space. But first we have to have some idea of why we're even doing this. Well, we want to begin here in this approach that I'm taking in this video presentation. We want to do it mathematically. Now, you can do it geometrically, and this is a marvelous tool. You can drag stuff, you can draw intersecting lines, spheres, circles. There is a 3D. If you click up here, you will see that there is, under perspectives, 3D graphics. Oh dear. Well, we're not going to click on it now. That'll be in a future lecture. We will be getting into spherical geometry very quickly, but you're already in it. This is actually the eigen of the sphere, which directly represents the sphere on a simple constant. It's actually a 2-to-1 relationship, and I'll show that to you. So what we want is to prove the foundational principle of inversive geometry, which you can learn from Zvezdelina Stankova on Numberphile, conducted by Matt Brady. Oh, I think this guy is beyond top-notch. He's somehow got supervision. It's very hard to make a reasonable presentation when it's also an interview, because you have to know something about what the person is going to say, or you can't really interview them effectively. Well, Brady is unbelievable. You know how he solves that problem? He asks about one question every 5 or 10 minutes. And just lets the person give the presentation themselves. Well, she gives a marvelous presentation of inversive geometry. It's called Inversion on the Circle. And all it says is, anything you can draw inside the circle also exists outside the circle. We're going to use that to show an interesting mathematical relationship, which to the best of my knowledge, no one has ever understood. Inversive geometry is, I guess you could say, understood, but how does that pertain to our situation of unitizing the circumference of the eigencircle? We want to unitize the eigencircle so that it becomes the basis of a new metric in real space, physical space. That's spherical space. That's what we discovered in the 20th century. Everything is in spherical space. The atom is, the proton, the electron. We know that the photon is a sphere. The Earth is a sphere. Why? The Sun is a sphere. Why? Galaxy clusters are spheres. Why? Gravity is spherical. Oh, man. That's a lot of sphericity for a little one-component number system to handle. Now, one of the things I'll be showing you is that the sphere also has an inside and outside, which means it too can be parameterized on a two-component number. Well, isn't that a direct contradiction? Think about that for a second. Assuming that the circle is a two-component number that has to do with the fact that one of the components is inside the circle and the other component of the number is outside the circle, can't you do exactly the same thing with the sphere? Of course you can. Well, that means you have two different versions of the two-component number system. I don't want to show you how that conversion works, but it is a second mind-blowing identity. These are identities, okay? These are mathematical identities. Nothing is more certain than mathematical identities. All right. So you can see that there's an inside, which we're saying has half of the numbers. Because in a two-componency number system, you have exactly two halves. Two halves, they're two columns. In one column is the first component, that's one number. And in the second column is the second number. In complexity, the first component is called real, and the second component is called imaginary. In our system, the first component is inside the circle, and the second component is outside the circle, and that's their relationship. The relationship between real and imaginary component numbers, is solved with a conjugate algebra, which is simply cross multiplication because you have to get rid of I to get the linear numbers out. In our system, I'll show you how to get the linear numbers out, but I think you'll have a very good chance of seeing it yourself. That's the reason the synthetic phase of science is so exciting is because this is when you solve the relational problems so you can see. True understanding is visual. And blind people have this. They just can't use their eyes to verify it, but they still use the machinery. So I always like to mention that. I get so emotional sometimes because I've seen blind people ride bicycles. And I was blind at one time, virtually with cataracts, and I wasn't riding my bicycle as well as a blind person it was. At scale, I mean, you'd have to say that's a pretty good trick. They click with their tongues. To use sonar like dolphins. Fucking unbelievable. Anyway, I'm going to give you something way more powerful than that. That just enables you to ride a bicycle. This enables you to see and understand the universe the way the universe expects you to see and understand it. That is the goal of science. All right, so this is the gateway. All right, what do we have here? We have an inside and an outside. We're saying one of the components of the two-component number system is inside. Well, it would be less than 1. Oh, very good. Therefore, outside, the other component is greater than 1. All right, you may know that I've mentioned several times John Horton Conway's discovery of the surreal binary number tree substantiates all this in a way that's worth knowing. Even John didn't fully see what he had discovered, same as Max Planck did not fully understand what he had discovered. This will show you what Max Planck actually discovered and what John Horton Conway actually discovered, for which he deserved a Nobel Prize. So yeah, we don't want to go to that side. That's a sordid, morbid aspect of modern science. It's just so blind that it's a new dimensionality of blindness. I will show you the reciprocal of that to get you out of the trap. So we have one number inside, one number outside. One number is less than 1, one number is greater than 1. In order for that to be consistent on the identity of the number space, they have to multiply to 1. In linear space, the numbers add to 0. That balances the entire line to infinity and beyond. Because that's what Buzz Lightyear would say, Daddy-O. Okay. Oh, this is good coffee. It's not spiked, but I get high on water. But I'm weak. I like substances. I have snuff under my gums right now, but it's in pouches. This is a major discovery in my small world. This coffee, I actually used to roast and grind my own beans. If you have never roasted and ground your own beans, you've never tasted fucking coffee. But I still drink this mud because it comes from my environmental upbringing. All we drink is burnt, stale beans. And I like it, probably because my biofeedback system keeps saying, more, more, it's that time of day again. Well, I've also had a hit of marijuana. So I'm flying on 3 drugs, not to mention the 3 prescription drugs, one of which I've run out of because I'm so poor. But I'm still alive for a while, so you better pay attention. But at least I'm not dripping brown sludge. I used to have Flex would appear. Here's a dribble line. Oh, yeah, about once every 5 minutes I lean over, and then I have to edit out every time I lean over to spit. Like a goddamn swamp creature. But I'm a happy-go-lucky redneck. I finally realized I'm a redneck. Okay, let's get going here. Not in the negative sense. A redneck is just someone who's been burnt by the sun on his poor, hapless neck. Yeah, it makes you ornery. Of course, you got a sunburn. Your neck is always... Well, you tend to be ornery. But, you know, when the sun goes down and the moon comes out, glory, how we're gonna shout. That's a real redneck. He's a dancer. He's getting out there. He'll fall down. He's not ashamed to let you see him at what he said. Like me. Medicine. All right, the downside of your professor. Hey, we're human. I'm not ashamed, I told you. I'm getting ready to go to the next level. If I need something beaten out of me, you don't need to worry, it's going to happen. I'm not looking forward to that, but come on, am I ready for heaven? Do I look like... Well, you... Peter at the pearly gates, what's that under your... Is that tobacco? You know, whatever happens after that. Well, I don't know, but I believe in the mercy and kindness and compassion of the Lord, but I'm not going to tempt him. Well, these shitty things. I'm starting to feel a little repentant and ashamed now. All right, at least I have a double Windsor knot tie, which, by the way, you notice I'm... Well, I don't know if you noticed... Pardon me. That's coffee burp. Tasty burp. God, I love... Oh, there's our train that goes by like 50 times day and night, blaring 150 decibel horn as it goes through just 4 blocks away. You've heard the helicopters, the low-flying planes, you hear a siren, there's all kinds of stuff going on. All of which is high decibel, distracting. I don't know what's wrong with my hairline. I never used to... Okay, that got rid of... It's like I have a reverse widow's peak. Alright, this is called a comb over, I believe. And my hair is falling out in the back. As long as I can't see it, I don't care what's happening back here. Yeah. Anything back here, I don't look anymore. Oh boy, this is strong coffee, man. Alright. So we have a number that's less than 1 and a number that's greater than 1 that are on either side of the surface and multiply to the surface. That's called the two-component parameterization of the circle, with a parameterization that nobody in the history of science has ever thought of, even though we know about inversive geometry. Just nobody ever realized if everything inside the circle is represented outside the circle, couldn't we justify that mathematically? Well, I just did. It's called the multiplicative number space. And as you know, multiply has a paired operator. There's plus minus for the line. Well, there's multiplication and division for the circle because it's two-component space. That's what we're proving. All right, so now let's see the number system. Everybody these days, against their will if necessary, is forced to consider if it's not mathematical, but we don't care. Well, it's that form of ossification, just a refusal to see geometry, that's one of the reasons that we have such a maniacal, psychotic physics department on Earth today. Just harebrained theories. Harebrained. Well, that's not the reputation science should have. I mean, anyhow, if we have a linear quantum jump from 0 to 1, which is the radius of this. This is the Planck length. This is the quantum circle. Because the radius is the smallest linear jump. That's called the quantum jump. But you can see that there are two aspects to the quantum jump. In 2022, I proved, using rigorous Euclidean logic that I used, to prove that a line, any line, like the line here, that line, that is embedded in spherical space. That is a calculus relationship, by the way. But the circle is not embedded in a grid. That's how we're doing it now in physics. It's the other way around. The grid is actually embedded in the circle. The aspect ratio is 6 to 1. Okay, now you know that. That's magnificent. That means that the Planck unit for linear distance separation, the Planck length, 10 to the negative 34th power distance on a line, has nothing less. That means that's imaginary space. It may mean something else, but you can't see what else it might mean because you only have one componency. You're only measuring distance. On the circle, you're measuring a ratio between two distance quantities, but we're going to see that one of the quantities is not spatial. You might guess that it's temporal, and therefore we're looking at the quantum of space-time. If you guessed that, you're a genius. But I can prove it. You are looking at the quantum of space-time. That's not all it might be. It's actually something far more profound than that. It's more profound than Einstein relativity because it actually gets the answer. Einstein did not get the answer. He got the relationship between linearized space, that's that grid, and another orthogonal component, which turns out to be linearized time. And even that is not quite stated correctly. It's the orthogonality between 3D space, which is cubic space, turning it into hypercubic space, which has an imaginary dimension because it's between all the three lines. In the same sense that Z is in between X and Y, X is between Z and Y is between Z and X. The same thing pertains in space-time, which is a 4D composition. Don't ever forget that. It's a 3-1 composition. Well, you know it's wrong because you're trying to relate an orthogonal imaginary one componency to a triply orthogonal grid extrinsic geometry overlaid on spherical space. We're going to integrate that. And the integral will be about 6 times more powerful from a certain very specific linear aspect. But it's got to be better. It's got to be more accurate. That's just the beginning of the insight. So, we have the quantum jump from 0 to 1. That's the linear spatial quantum jump. It's from 0 to 1 because there's nothing in between 0 and 1. Right? Right? Not quite. There's something there or there wouldn't be a jump at all. What there's not is a number for it. That indicates an imaginary number space. In linear space, there has to be. Well, Einstein added it when he added time. So it's imaginary time. But time is already a linear quantity in the universe. I proved that, so you can accept that. Time is linear. Well, we know that because it only goes in one direction. Direction in what? All right. What we want now is to simply emulate Euclidean numeric construction. So the next step is going to be Euclidean in logic form. Instead of the jump from 0 to 1 on a line, which is the radius of this circle, is the linear quantum jump. That's embedded in a higher space, as I proved. So what is the circular quantum jump? There are two that are locked into one number. There are two quantum jumps that you could say are simultaneous, but that underscores the paradox. Simultaneity is not considered a spatial concept. There is no such thing as simultaneity in space. Okay, I want you to think about that a lot. This is the time to ask questions. I should be at Madison Square Gardens. I should be at Harvard or Yale or Stanford or Cambridge or Oxford or Göttingen or Milan or Dubrovnik or Moscow. It doesn't make any difference, but I should be lecturing somewhere. You see why? This is the imperative of science. This is not me being megalomaniac, although it may sound like it. Well, that's the coffee kicking in. All right. All right. So we have the linear quantum jump. What would be the spherical quantum jump? Well, it has to be from the Archimedean center. On the line, that's from 0 to 1. On the circle, it begins at 1 and goes in two directions simultaneously. Just accept that for now. Some kind of new definition of simultaneity that's not relativistic, because there's no such thing as simultaneity. For the same reason, there's no such thing as co-spatiality. You can't have something at the same position in space. The Pauli exclusion principle forbids it. So you can't have simultaneity in space, that is spatial. You can't have spatial co-position in space. For the same reason, you can't have simultaneity in time. Everywhere where there's time, it's unique, just as in space. Otherwise, they wouldn't correlate at all. Right? I think you're starting to see some real subterranean stuff going on here. So let's make sure we rationalize all this so none of this is spooky. We haven't even gotten to the spooky part. But we do need a sound mathematical basis for our new geometry. What is the circular quantum jump? It's not from a point. You're looking at the circular point. What is peculiar is this point has an interior. That does not make sense to us. Well, if it has an interior, it must be spatial. Not necessarily. Let's axiomatize our doubt. Let us assume that space is only outside the circle. Well, then you would probably want to answer the question, then what is inside the circle? We're going to give it a placeholder name just so we can refer to the inside of the circle, because now we're axiomatically stating that what is outside the circle is space, to the same proportion that space goes out on a line. Here, space is going out on a circle. But there has to be a smallest circle. That is not a point. It's the Archimedean balance of the system, which has to be an object, and it has to be equivalent to the point. Well, the point has no equivalency because it's a derivative. The center of this circle is a derivative of the circle to the same proportion that 0 on the line is a derivative of every number, because it's the frame of reference for every counting number. That means every number. Because when you unitize the number line, it's entirely counting numbers with nothing in between them. And this goes down to the paradox of quantization of continuity. But what you're looking at here is a continuous line. So if it can be parameterized, it must be on the inside and outside in order to generate the surface from two numbers, one of which is inside, one of which is outside. This is the mathematical basis of inversive geometry, which is so profound that I strongly recommend you watch the two videos produced by Matt Brady on his YouTube channel Numberphile, where he interviews and allows to give the entire presentation, which is what he does. Magnificent technique. You want to give the scientist scope. A mano-a-mano interview such as Kurt Jai-Mungal engages in is ineffective for this level of science. You need to let the scientist talk on their, as if the interviewer weren't even there. So that's what Matt Brady does. And so Zvizdalina gives you, you will not regret watching that video, and you might want to watch the second one. You might also fall in love with Zvizdalina, but she's married, so be careful. All right. She's from Bulgaria. Oh, yeah, she's Slavic. Oh, boy. I married a Slavic lady. She died of cancer, so that made me sad. But then I turned to science, and now I'm okay again, because heaven overrules the petty foibles of men, including cancer. All right. So what's the quantum jump in circular space? Well, it has to be from 1. Well, what's the next number? Ha! It's 2. Well, Max Planck proved that that is actually the correct lowest number for two-component space, although he didn't see that. I did. So there are two numbers that split from 1, because 1 is two numbers. It's 1 proportion 1, because that's the proportionality of the vertical aspect, which is linear, and the horizontal aspect, which is linear. If you can perfectly compose that, you get 1 proportion 1. That is the value of this surface. That is the number 1 for the circumference, where the radius is an irrational, unreal number. 0.159, as we composed this circle here, has a radius of 0.159. That is not a circular number. First of all, it's a one-component number. Second of all, it's irrational. And third of all, it's less than 1. Less than 1 makes it a candidate, but the other two, it's not a circular number. It's a circular component number, such that on the Pythagorean theorem, if you use the right mathematics, you can make 0.159 vertical and 0.159 horizontal turn into unitization of the circle. And that has to do with tau and the inverse of tau. But we already went through that. I'm just reminding you, this is all transparently obvious so far. So instead of 0 being the center of 1, 2, 3, or 4D, we now have the circle at the center of two-component space, where one of the components is less than 1 and has to be composed of the numbers 1 and 2, and the number outside, which represents another circle. Both of these represent another circle, because we're composing the circular quantum jump instead of the linear quantum jump, which is on the radius. So the circular quantum jump has to be split. in two opposite directions. We're going to say opposite until we define what that means. But if you look at the line, the same thing happens. If the line were composed in two componency space, the first number would be 1 comma negative 1, wouldn't it? Of course it would. Why? Because they add to 0. And then when you get to plus infinity and minus infinity, you add them, and they add to the Archimedean center. So remarkably simple. Why didn't they teach it to us this way in school? Because mankind is not as smart as Great Uncle Sam here. And that is my name and title from now on, because I am getting megalomaniac. But I'm not going to be invading Sicily with my fleet of tuna boats tomorrow, you know what I mean? Because I'll keep drinking coffee, and I'll probably have some more beer to the detriment of my liver and kidneys and heart, and probably my brain eventually, but not yet. As long as I have a brain, I'm going to give you the secrets of the universe. So we're getting down to it, and you can tell I'm getting excited. It may be time for one of my favorite God-given drugs. And this is for you children. Don't do this until you know how to use a lighter, because I've burned myself so many times. I much prefer matches, but I'm in the space age, so I pretend like I'm with NASA and smoke out of a pipe with this space age device that got us to the moon, if you know what you're talking about. God, it started affecting me even before I had totally inhaled. All right, let me just have a quick bite. I should probably put this on pause, but I'm just shameless when I'm this excited. Oh, it's gotten me in trouble. I don't regret a moment. Well, I wouldn't want it to be replayed in many cases, but oh well. Breakfast with the professor. I hope you're taking a break, because it's been 2 hours and 20 minutes, and I'm not even... At least it's not snooze dribbling. And this is, in fact, a double Windsor nut. I'm giving the Tylen from my pituitary glands, or Tylen glands, I mean, a chance to dissolve the carbohydrates into simple sugars. That really happens. Oh, so it's miraculous. People who say they don't believe in a creator or a designer, I just don't have time for such people anymore. Really? Oh, you're an atheist? Dr. Richard Dawkins? Well, you're some kind of witch doctor then. Shouldn't be talking to children. No, I could get in trouble any second now. Just start gnashing my teeth. No. Totally stable, but you see, I'm not used to presenting myself. I'm a loner. I try to be alone. Except when I meet the proper woman, in which case I'd never want to be alone again until she dies, and then you have to be alone again. That can be jarring. Why you need to keep eating. You need to... This could be it. We saw him die. Well, we'll give him a warning or a strike. He shouldn't have died. That's prejudicial to living people. Who does he think he is? All right. A little more coffee. Another drug. By the way, carbohydrates are drugs. Sugars are drugs. Everything that runs through your veins is a drug. Proteins are drugs. I believe oxygen is a drug. Water is a drug. Well, the illimitability of the spatial universe can also drug a man. Let's see if we can get a handle on that using something called rational logic. So we know that the jump is from 1 to 2, which means that defines our two reciprocal numbers. The number inside 1, 1 is 1, 2. And the number outside 1, 1 is 2, 1. I think you could teach that to a second grader. Don't you? I know I could. Doubt that anybody else could, though. Children, trust me. Oh, they see I'm just pretty much the same level they are. Don't you agree? Oh, God. Well, so where are these numbers? Well, let's find out. Halfway to the center from the surface would be half of the inverse of tau, right? Well, we can just bisect the line segment. We can use this tool to do so. Up here, segment. But don't we want to bisect it? Let's see. What do we do to get the bisection? Perpendicular bisector. That might be it. Yeah. Let's try perpendicular bisector. What is it? Select 2 points. Or one segment. Well, let's do that. Click on this, and now it's waiting. I click on the center, and I click on, oh, look what it's doing. And it's showing me what it's going to do, and I click there. Oops. Click there. Why is it not? Oh. Oh, shit. I'm not sure what's happening. Oh, look. I think, is that, no. I'm not sure what this thing is. Okay. I'm going to get out of this tool. I thought I knew what I was doing. Oh, I know. First of all, we need to make a segment. Select 2 points. Okay, segment. Now click on this. And it shows me you're doing the right thing. Click that. Right. Now that should have, yes, down here, I'm going to highlight it. Down here, you see it says 0.159. So we want halfway, right? So we can represent 1, 2. Halfway will be 1, 2. You have to get the order right. It's 1 over 2. It's 1/2. Correct? Yeah. And then we'll be able to find 2 on the outside. Correct? Of course. So, how do we do it? Well, we click on this, and we want perpendicular bisector. Now it should work. Click on that. Now select this point, and oh man, I don't know. I'm not sure I understand how this works. Maybe you're supposed to, if I click on, oh, did that do it? Yeah, I think so. Oh, it thinks I want to do it again, so click up here, and I think that's a perpendicular bisector. What's half of 0.16? Should be about 0.8, right? Let's zoom in. Oh, look at that. So we got it. It shouldn't be exactly 0.08 because it's not exactly 0.16 for the radius. All right, so that is halfway. Well, now we can compose a circle. I'm sure I'm exuding enormous confidence to you. You're that's not it. Oh, here it is. So we want a circle with center through point, or we want circle with center and radius. Okay, we don't want that, so we want this one. So you click on the center, and then just drag the mouse until this intersects. Oh, it locked. I told you this is a frickin' intelligent program. You can turn that on and off, by the way. So click there. Now that should be a circle with half the radius. Does it look like it? Now up here I want to click on this so I don't make another circle. I'm going to click on this. Right click. I just inadvertently zoomed on it. Settings. Style. Thickness a little more, and color, we'll just make it orange, maybe a little darker there. All right, then close this, and now we have 2 concentric circles. We want the other one on the outside. That's easy to compute. It will be at double the distance from A to D. Now what we can do now is simply take this line segment, which I will click on, and go to Settings, Segment AD. Oh, okay. Sorry. I could always edit this later. What we want is to compose this radius to twice its length, correct? I don't know of a way to just copy the line segment and move it. So for now, just to save time, I'm sorry, this will be refined, certainly in the future. About the double of 0.15, that is 0.16, would be 0.32. So we're just going to select that as a point. And to do that, we select the point tool, intersect. What is this? Midpoint or center, attach, detach, point, attach or detach point. There's a lot of this I don't understand yet. It's so powerful, it's just mouth-watering. So I'm going to make a point at 0.32, and then remember to come back up here and turn off my tool. I'm going to zoom to see if it did snap. I don't know if it would snap here. I doubt it. No, it did not. So let's adjust that. This should be a movable point. It is, so now we have it on 0.32, which is not exactly accurate, but it's pretty good. For visual purposes, it's certainly accurate, since we don't have that kind of discriminatory vision to make those kind of minute adjustments. So now we want to make another circle. We'll use the circle tool. Circle with center through point, that is what we want. Get the center and this point, which it snapped. Okay, now that may look like an atomic system. There is a very good reason for that, but we're not there yet. First we need to get, I need to turn off my tool. Good thing I remembered. And click it again. Okay, so now we just want to have a little more space. And over here I'm just going to give us a tiny bit more space. If I can remember how to do this, I'm not sure that's doing it. I think this is the maximum amount of space, but we want to increase the resolution. I'll just adjust the camera a little bit. And now we can recenter this by clicking and dragging, and now expand this. And now I think you have a pretty good idea of, first of all, this inside circle, which is in Auburn. That has a radius of 1/2 of the radius. This circle is the center with a value of 1. This is a circle with a value of 1, 2. This circle has a value of 2, 1. What we want to prove is that those two circles are harmonic on the center circle. This is the inner circle, making one of the two component linear numbers, although it's linearizable. It's 1, 2. 1, 2 is how we'll say it, but you could say it several ways. It's 1 proportion 2 with a colon. It's 1 over 2, and that is called a fraction, and it's also known as division, but the correct nomenclatural representation of that relationship is they're proportional. And if you invert the proportionality, it inverts what's inside the circle to what's outside the circle, which are two circles that therefore represent the center. And these two component numbers, this circle is a number, this circle is a number, and in combination they represent another number, which is, all three of them are two component numbers, But this one contributes to the two-componency. This one contributes to the two-componency. In one componency space, that is addition to 0. In two-componency space, it is multiplication to the center. Now, the paradoxical nature of the center here is that it's a surface, which means it has an inside and an outside. And now we've just been able to compose the two numbers that represent that relationship in a closed, coherent, relatively continuous number system. And now I need to show you the quantum jump in circular space, which is a two-componency quantum jump, and therefore it's in two opposite directions. What I then will show you is that is a conjugal relationship instead of polaric. So you're not seeing polarity here. Polarity, but you're seeing the two-componency equivalent of polarity, which gets into some new nomenclature which does have a derivative representation in linear space. But remember, this is not Kansas anymore. This is two-componency space. This is circular space. This is in-out space. It's not left-right space. It's not plus-minus space. It's not plus-minus space. But there is another relationship that is not polaric, where the two balanced numbers of the line add to 0 all the way to infinity, making essentially the value of the line 0. The circle has a value that is not 0, because it does not involve additive identification to the Archimedean of the object. Instead, the Archimedean of the space, there is space now. The Archimedean of the space is the circle, inside of which are numbers less than spatial reality. At the surface is the intersection of non-spatial space, which is inside, and spatial space, which is outside. And I don't believe I ever got around to telling you what is the placeholder term we're going to use for the space inside. Anti-space. And later I'll show you by anti we are incorrect. But anti-space is the simplest. But you can be more precise, and in fact you must be, because anti implies polarity. Anti means linearly opposite, although not strictly that's how it's used. This is not polarity, it's conjugality. Well, what's the difference? Well, this is 180-degree relation. This is 90-degree relation. This is 90-degree relation. So they're perpendicular. What's perpendicular? The inside and the outside are perpendicular. And I'll show you that that's not readily apparent, that the inside of the circle is not the opposite of the outside. It's the perpendicular aspect of the outside. The outside is space. So what does the circle represent? It represents the number for space, which is an ever-increasing number, 2, 4, 8, 16. That's a geometric progression, except that for now, because those are the representable numbers. The conjugate number that must accompany that jump, that is the circular jump, is from 1 to 2. It would have to be. And that makes the number 1, 2, 2, 1. It should be the other way around. That makes the frequency wavelength relationship. That is 2, 1, 1, 2. I hope you understand I'm using notational abbreviation. It's so simple, it can be stated this way. It's the number 1, 2. Okay? You could also say it's the number 2, 1. If you say it's the number 2, 1, you're talking about frequency. And the reciprocal of frequency is 1, 2. That's called wavelength, which is a form of length, but it's inaccurately named. So that's what Max Planck discovered, is the quantization of numeracy at the quantum scale. That the true quantum jump is not from 0 to 1. The true quantum jump is from 1, 1, 1, 1 to 2, 1, 1, 2. That can be abbreviated. It's the jump from 1, 1 to 1, 2. Both of those being split numbers on multiplication, and both of the components being anti-multiplicative. That's called division. That's an inaccurate word. You must not call that division. There's no such thing as division in the universe. Is there such a thing as multiplication? Yes, and therefore I'm wrong in saying there's no such thing as division. But when you see division in two-componency coherent rational space, it is proportion. And it's the proportion of what's inside to outside. That makes the surface value unity. And that represents the uni in universe. This is the geometric universe that has a quantum center that is imaginary and an exterior which is also imaginary. And so imaginary is the key word. That imaginarity, you have to, this is where you begin to change your mind, to see imaginarity. Because what we're looking at here, first of all, is the center of gravity, right? Which goes to a point. That's been proved. Why does it go to a point? What happens at that point? Well, since gravity is nothing more than a relationship between two quantities, when you get to the center where they're actually correlated, the quantum correlation of the two quantities is a rate. Well, a rate is a circle. But a circle confounds the bejeepers out of us because we can see it has an interior. You must train your mind to both see and not see the interior. And it depends on context, because it depends on which number system you're using. Because each number system represents a different geometry. You can see at a glance that the circular number system is so much more powerful than the linear number system that there is almost no comparison. Only circular space gives a view of reality. It was discovered in the 20th century, but nobody finalized it in the synthetic stage. I'm taking up the slack and finishing the progress of science from the 19th to the 20th century. What should have been realized in 1910 was only realized a century and a tenth later, and a fifth after that, on an irrational distance of time on a timeline. Because it was in 2022 that I figured this out. This is the answer. This solves everything in physics. You're seeing it geometrically. What I'm attempting to show you now is how it translates to physicality. And this is where it gets spooky, of course. Who can define reality? Well, let's take a shot at it, shall we? And we'll close this off before 3 hours. The circle that's inside one, we're saying, is in orthospace. That can be proved, and we're going to prove it now. So we're going to call it by the name that we think it's going to be, and then prove that that is its name. It's orthospace. This is a characteristic of space itself that not even Einstein saw. He saw that there had to be imaginarity, but he was trying to compute for gravity. That's monopolar, so he had quite a task doing that, but he solved it with hypercalculus. He got the interpretation of the Poincaré-Minkowski construct. So Einstein was the union of Poincaré's genius and Minkowski's genius, and Lorentz. Enrique Lorentz. So the circle outside of 1 is space. And now we have the quantum jump in space. It's a circular jump. It's a circular jump from 1 to 2. Correct? Not quite. This is circular space. Every one of these numbers is a circular number, so it's a proportional number on whole numbers beginning at 1, the next of which is 2. So this is the jump from 1-1 proportionality to 2-1 proportionality. And now you will want to ask, what are the units of this proportionality? What are the units of the component numbers of the component numbers? The component numbers of a circular number are two component numbers. The components of the components are linear counting numbers. They're one component distance metrics. But in this construct, one of them is not distance, because distance only exists outside of the 1-1. What's inside the 1-1 is orthodistance, and it would be measured as the distance in time if you're using time-space. That is remarkably naive. But in its naivete, it gives the ability to travel into outer space. So we have space, and here's the jump from the surface of space to the first spatial quantum. What is in between? I'll tell you what's in between. The same thing that's in between 0 and 1. And if that were true, we might as well throw up our hands because we'll never understand the universe. There has to be something in space to make space. Space cannot just be these circles. Why not? Because there's space in between the spaces. So it is continuous. But the jump from 1 to 2 is not continuous, isn't it? Think about that for a second. Have I stated all the facts yet? No. I've only given you one of the component numbers. That number never exists alone, and that shows a universal relationship, because 2-1 is not a complete number. If you're looking at physical space, and you want the translation between physicality and geometry, then you're going to have to make it work with the numbers. Otherwise, it's incomputable, and you must be wrong if it's incomputable. We know that because of microcircuitry logic, which is binary. I'm going to tell you something. It's not just binary unless you define binary very carefully. What I'm showing you is physical binary space. But what the computer cannot do, because it's using linear logic, is see dual binarity. It's dual binarity. Because one of the binary numbers is space, and the other binary number is orthospace. That's inside. And I need to show that to you now, but before I can show it to you, I need to develop the metric of circular space. We have no metric yet, although we can see it. There is no metric for the line either. Unless you accept 0 to 1. If you accept the jump from 0 to 1, which is from non-existence to unity, there is nothing in between. That's the quantum jump on the line. It's the jump from non-existence, which is 0, to unity, which is the quantum on the line. Now, in circular space, what we have, since it's a two-componency Archimedean, it's not non-existent. You're looking at it, but it's semi-non-existent. The circle is only existent in flat space. It's a circle. It's in flat space. but the universe is not in flat space, except in terms of motion. Accept that for now, but that is the antithesis to space, which goes by several names. Einstein said it was time. I say it's energy, but when I do say it's energy, therefore it's angular momentum. And that being the case, it's actually motion, which is the definition of force. That is, it's the axiomatic basis for the definition of force, which is construed as a one-component number in Newtonian space, because it's linear impact. There's no such thing. There is only spherical impact. And spherical impact is the intersection of two spheres on their mutual surface, and that it cannot be quantized. Bošković proved that, and he has the mathematic and geometric proof, which I proved that he proved. He could not prove it. I can. So, this does have a lot to do with a curve. Well, you're looking at a perfect curve. The circle is the curve. Every other curve, so-called, is a distortion of the circle. But what they all have in common is two-componency. Now, what we're looking at is a special case of a curve where it's closed. And that is the basis of angular momentum, energy, and time. But it is not the basis of space, except in contraspace. That's gravity. Gravity occurs in contraspace. Accept that for now, because it can be seen from one of two perspectives, where it's actually a force, and the contraforce would be a pseudo-force, which in that case would make light non-spatial. Space is only outside the unit. The unit is the intersection of contraspace and space. The question then is, how do you characterize contraspace? Well, first of all, how do you characterize space? Well, space, if it's conceived as a closed line system, as we're proposing now, then it's made of concentric circles. That describes the flight of the photon, is on concentric circles. It also describes gravity, which is also on concentric circles. So this is the unification of gravity with electrodynamics. You're looking at it. It's the relationship between an inner circle in contraspace and an outer circle, which is spatial space. And the inner side of one is contraspace. And that can be proved in several ways. I hope you're a little bit baffled, but I hope you're far more satisfied than baffled at this point. But if you are baffled, you can line up behind every other mathematician and physicist who has ever existed. I am the only man who understands this. If you get it, you'll be the second man to see it. So the two numbers that compose the first counting number in real space is 1, 2. It's not 0, 1. That's the quantum linear jump. 1, 2 is the spherical quantum jump, which also looks mathematically exactly the same in circular space on the eigen of momentum. That will be the eigen of time-space intersection, but in order to see time-space intersection orthogonally, which Einstein proved you can do, you need to see orthogonality in circular space. And that will be the orthogonality of space with energy. And the eigen that has the value 1 is energy. Do you know why? Why is the eigen of the quantum circle 1? Do you know why? It's two quantities. But which two quantities? We know one of them is space. But here you have to switch from linearization space to sphericization space, which you're looking at. So the radial jump, which goes like this is a force line in circular space. It's a force line. You think of it, oh my God, that confuses the fuck out of me! Because only this is a line. Why do you keep saying line? Rotate it. Rotate the line. That's force. That's force. That's the only definition of force, is a rotating straight line. The only thing that matters, the only thing that can be measured, is the circumference. But something is happening inside, because that radius goes all the way to the center. What is rotating? Is it time? Is it motion? What is it? Is it energy? Time? Motion? Angular momentum? What is it? Sine? Cosine? What is it? It's imaginary. That's the first thing. Well, it's imaginary, but it's not less than real. It's greater than real. You're looking into superspace. This is the embedding space of space, because space has another dimension that we can't see. We interpret it as time, but it's actually energy, because energy is a two-component number. There's a two-componency to the circle, which is energy. You know how energy is defined? How is energy defined? How is energy defined? Max Planck discovered it. What is it? It is called frequency times wavelength. Frequency times wavelength is energy. What is the linear number result of multiplying a frequency with a wavelength? It is the number 1. Do you know what physics knows about that number 1 now? That is unitized light speed. So you're looking at light speed. You're looking at space-time, although I'm getting to that. So the actual relationship that exists in orthocircular space, this is inversive geometry, inside and outside are perpendicular. Here's why. The force that is, you could conceive this as centrifugal force, the internal force that makes a photon, is a force that makes the surface that we call a photon. It's composed of two values. What two values? Well, light speed is linear distance over linear time. What you're actually looking at here is circular distance over circular time. But time is on the circle. Space is outside. Nothing is inside. We're getting to what's actually inside. But if it's orthogonal to the force line goes out from the center and stops at the surface. That's the limit of the centrifugal force that makes the circle from the inside. Well, the circle isn't just made from the inside. It's made from the union of centrifugal and centripetal force. Because that circle can only be there if there's a radial radius. That's a pressure called a force, called centrifugal force, which is unitary in circular space. So that's the value of the inside from one of the component aspects. It's the pressure that keeps the circle from disappearing into zero. That's the definition of a proton radius. Now for the electron radius, we go to the other side of the unitary surface. The unitary surface is held at its permanent position as the quantum of circular space by an internal pressure that's balanced with an external pressure called centripetal force. They are orthogonal. So to the proportion that 1:2 is centrifugal force from the inside, making the surface, Why then doesn't it fly into infinity? Because of 1, 2 acting from without. That's the pressure of gravitational space, gravitationalized space. The interior is centrifugalized space. The exterior is centripetalized space. Those are orthogonal. That's frequency times wavelength. So which is which? And there's nothing inside, because since they're orthogonal, when the exterior pressure reaches the surface, this is the interface between the two force fields, it goes sideways. At the infinitesimal, where the force line coming in, pressurizing the circle to 0, towards nothingness, it can't pressurize further. But where it stops and cannot pressurize further is a hard right angle. In quantum space, you're looking at it. So what it encounters is the external force, which from the inside to the surface, at the surface, is also orthogonal. And so the centrifugal force holding the circle at its radius is forced sideways onto the sphere. The force coming in, which balances the centrifugal force, creating the circle at the center of space-time, we'll just call it, but it's actually space orthospace. The orthospace is on the circle. It will take a while. You'll have to master this first before I show you the geometry of the inside of the circle, which is hyperspheric. But the surface is simply the intersection of two force fields. It's the intersection of the out sphere going in with the in sphere going out. That makes light speed. We interpret it as space-time, and here's why. The circle, which represents 1, 1, is one space to one something else. We know that it's spatial because that makes the spatial center. But it also makes a right angle in spherical space on which must be the reciprocal of the centripetal force. But you can see that that makes the circle, the union, the conjugal union, the multiplicative union, which is cross-multiplication, which is at a right angle in spherical space. That means that the circle, which is 1, 1, is 1 part space per 1 part contraspace. And now we need to find out what's in contraspace, which is one of the conjugal aspects of this circle. So this circle is not completely spatial, and it's also not completely contraspatial. But it represents the right angle between two forces. What are those forces? One of the forces is the forces that is associated with space. I think you know what that is. It's protonic gravity. So what's the other one? We've identified one of the particles and one of the fundamental forces that's pulling in from it's pulling the outside in, but it can only pull the outside into a surface because there's another force that is conjugal with protonic gravitation. That is electronic centrifugality. So the electron is the contraparticle to the proton, and those are the only two particles. There are no other particles, period. There are no other particles. So the solution to the Democritus enigma of the smallest bit of material is now solved. This also solves a whole list of paradoxes, which we'll be able to get into eventually, but that's 3 hours. And I think that's enough. I hope this helped you. I may not be around much longer, and I'm just going to tell you explicitly. Unless someone interviews me, this information will be lost. No one will benefit from my insights. That would be a tragedy. It would be a crime against humanity for me to withhold this information. And so I've devoted the last 3 years of my life thus far to exposing the truth that you can perhaps use for your own human equation. I guarantee you'll be wiser than all your teachers if you get this, and you'll be, eventually, as I am, the happiest man on earth, assuming you solve your moral dilemma as well.
There's a source in the universe for the answers to both of those questions. I already dealt with the emotional, religious side, the philosophical side.
Once you've had black, you can't go back.
I need more coffee, more drugs, more oxygen, more water, more beer. And, don't you think this double wins or not? I'm doing this under the orders of heaven to give you guidance on the way of heaven. And we'll be right back. Stay tuned.